Hello, this is Ms. Heaton signing in to talk with you about chemical bonding and the different types of bonds that form. In this lesson, you will learn to examine the differences between metallic, ionic, and covalent bonds using the elements location on the periodic table and properties. This is objective 5.6. We're going to be looking at 4 different models for bonding today, their properties, and what determines the kind of bonding that's occurring. But let's start with the most important thing. Why? Why are these differences in properties apparent between different substances? For example, why do some substances dissolve in water, while others don't? As you can see in the picture, we've got some salt that does dissolve in water, but other things like sand won't. And then, why do some things conduct electricity? You know, like they say, don't get in the ocean when it's a lightning storm because it might conduct electricity and electrocute you. And if you're touching metal, same thing. But other things don't conduct electricity. Well, this has to do with electrons. Electricity is just the flow of electrons from one place to another. And so both of these questions can be answered by looking at chemical bonding. We're going to look at these 4 kinds of bonding: ionic, molecular covalent, metallic, and network covalent. So first things first, what exactly is a chemical bond? It's just an attraction between 2 atoms holding them together in space. So if you have an atom by itself and it finds another atom that it's attracted to, those 2 can bond based on their electrons. Those electrons might be transferred or given to one of the atoms, or they might be shared between the 2 atoms, and that determines the kind of bonding that is occurring. And this is what determines those properties that we observe, such as, does it conduct electricity? Does it dissolve in water? And so the 4 models we're going to look at are these pictures that you've already seen a few times in this video. Take a look at these for a second and notice what they represent. These pictures are models that illustrate what's happening to the protons, neutrons, and electrons in any substance that has bonding. The red spheres represent the nucleus, which remember has the protons and neutrons, as well as any core or inner electrons. The blue shaded areas, like you can see here and here, all over here, and then in these lines here, those are the valence or outer electrons, and those are the ones that primarily determine the kind of bonding that occurs. And so pause for a second here and see if you can explain the difference in the electrons' locations between all 4 models. When you're ready, let's go on. We're going to examine the bonding models that contain metals. There are 2 types of bonding that metals can do. The first is a metallic bond. This is what you find in something like aluminum foil. This will not dissolve in water, but it will conduct electricity even as a solid. So if you, like we did in class, tested aluminum, it would be able to light up a light bulb. And here's why. Look at where these blue electrons, now electrons aren't actually blue, but in the picture they're shown as blue. The electrons, the valence electrons, are able to freely move about from nucleus to nucleus. And that has to do with the properties of those metal atoms. And because the electrons are allowed to move freely, they can conduct electricity, because an electron here could go whoop over here and then over there and over here. It's like a big sea of electrons. So it does conduct electricity. Also, it doesn't dissolve, because dissolving means water would have to get in here and pull this atom off. But it can't, because there's electrons in the way. There's no gap to break apart the metal foil. The second kind of bonding we're going to look at is ionic bonding. In an ionic compound, you will be able to dissolve it in water, and it will conduct electricity when it's dissolved. An example of this is salt, sodium chloride. As you've seen in the lab, or maybe even at home, if you try to make a saltwater solution to gargle, you can dissolve it in water. And that's because what happens is water gets in here and separates one atom from another. So you can pull off this atom, and then you can pull off that atom. And the reason for that is because look at where the electrons are at. They're only around every other nucleus. What's happening here is that the valence electrons from one of the atoms, like this one, are transferred or given to another atom, to the non-metal atom. So we're going to look at this more later, but basically metals give up their valence electrons and non-metals gain them. And so they can conduct electricity because they can transfer electrons back and forth between the 2 of them. And they dissolve because water can get in and break them up. both of these kinds of bonding tend to be solids. Metals are typically hard solids. Ionic compounds crumble if you try to bend them, and they will dissolve in water. So they may appear to be liquid, but that's really just because it's a solid dissolved in water. Okay, so those are the only two kinds of bonding that can occur if you have a metal. If it's pure metal, it's metallic. If it has a metal atom and a nonmetal atom, it is ionic. Now, what if there's only nonmetals in your substance? Typically, if there's only nonmetals, you're going to see a covalent bond form. And break that word down. Co means shared or between, and valent has to do with valence electrons. And so here, valence electrons are shared between the atoms. This typically only happens between nonmetals and metalloids. And we're going to talk later in this unit about why that is. It has to do with electronegativity and polarity. But covalent bonds tend to only have nonmetals and metalloids. And there's two kinds of covalent bonds. The first is a network covalent bond. These are things that don't dissolve in water and don't conduct electricity. They're very hard solids, like diamond or sand. And here's why. Look at their bonding structure. The valence electrons are in this grid. They're very firm, they're very set in place, and they can't dissolve because water can't get in and separate because there's electrons in the way. And they can't conduct electricity because look at where the electrons are. They're in these fixed lines and there's nowhere else for them to go. On the other hand, you may have a molecular covalent bond. The difference here is that it may dissolve in water. Not all of them do, but typically they will. They still do not conduct electricity, like the network covalent bonds. But another difference is that they often are liquids or gases. For example, alcohols, including the kind that you can drink once you are of age, and then carbon dioxide, which is a gas. So network covalent bonds are solids. Molecular covalent bonds tend to be liquids or gases because look at how the valence electrons are shared. They're only between some atoms, like this is it's electrons between two atoms, this is some electrons between two atoms. So it can dissolve, typically, because water can get in and separate one molecule from another. They're discrete units, whereas this one, there's no way to separate it into different molecules. It's all one big unit. Also, they don't conduct electricity because there's nowhere for the electrons to be transferred. They are already shared between two atoms. So those are the four kinds of bonding. Hopefully by now, you could explain the differences between metallic bonding, ionic bonding, and the two types of covalent bonding. And you talk about where the element is on the periodic table, whether it's a metal or a nonmetal, and its properties, whether it conducts electricity or dissolves in water. If you feel like you got that, click on through and take the quiz that goes along with this video to make sure you understood the concepts. If you feel like you don't really get it, so you take the quiz, you miss a few things, or you are unsure about the activity we did in class, keep watching. But otherwise, hit pause, go take that quiz, and then come back here. Okay, I'm going to talk about a few of the analysis questions that you saw in your lab in class to help you kind of further explain the bonding properties. So this is analysis question number 3. It asks you to group the things into the substances that conduct electricity and those that never conduct electricity. So check your answers for this chemical formulas row. Make sure you have everything in the right category. And then look at the generalizations that I made. For the things that did conduct electricity, aluminum, copper, sodium, calcium, copper, those are all metals. So there has to be a metal in it if it's going to conduct electricity. The things that were pure solids, so aluminum and copper, these two only conducted when not dissolved. Well, those are our metallic bonding things. They don't dissolve and they conduct electricity. And then the other three here, sodium chloride, calcium chloride, and copper sulfate, these have a metal, as we pointed out, and then nonmetals, chlorine, sulfur, and oxygen. So those are ionic because they have a metal and a nonmetal. And they conduct electricity, but only when dissolved in water. Now let's look at the things that never conduct electricity. Notice they all have carbon, hydrogen, oxygen, silicon. Those are the only elements in them. Those are all nonmetals. Remember that hydrogen actually counts as a nonmetal for reasons we're going to explore later. So these are all covalent compounds. Based on their dissolvability, you could say that these are network because they did not dissolve. and that these were molecular covalent because they did dissolve. Okay, so that's question 3. Question 4 asks you to make a flow chart, and there's a lot of different ways you could do it. So if yours is different, do not change it. Keep yours, but make sure it follows a similar thought process. So one of the first tests we did is to see if something dissolved in water. And it either did or it didn't. I mean, there are some categories where it kind of dissolves. We'll get to those later. Now, we could then ask, well, of those that, yes, did dissolve, did they conduct electricity? And it would either be yes, they did when it dissolved, or no, they did not conduct electricity ever. The things that did dissolve and did conduct, those are ionic. Sodium chloride, calcium chloride, copper sulfate, they have metals and nonmetals in them. If you follow this other path, dissolves, but it does not conduct, what category would that be in? That would be molecular covalent, because it does dissolve, but it does not conduct. Water, sugar, and ethanol fell into that category. They only have these nonmetals in them, including hydrogen. So those are molecular covalent. Now let's follow this other path, those that did not dissolve. So if they did not dissolve, but they did conduct electricity, what category would that put them in? Well, that would be like aluminum and copper, which are only metals. They're found over here in the yellow part of the periodic table. So that's metallic bonding. And then finally, let's follow this path of those that did not dissolve and they didn't conduct. Those are network covalent because they have only nonmetals and they didn't conduct or dissolve. So sand and parafilm fell into that final category. So again, you could arrange yours in a different order as long as there's a logical flow to your chart. Finally, question 5. Isopropanol, will it conduct electricity? Well, let's look at it. It's only got carbon, hydrogen, and oxygen in it. Those are all nonmetals. So that means that it's a covalent compound, and neither of our covalent compound categories would conduct electricity. You could probably predict that since it's a liquid, it will be molecular covalent. If it had been a solid, you could have said it was network covalent. And then finally, think back to our pre-lab with the Gatorade sports drink. Based on those results, what could you conclude about it? Well, it has to be ionic because it did dissolve in water and it only conducted when it was dissolved. Those are properties of ionic compounds. So that means that it has a metal and a nonmetal in it of some sort. And if you want, you could look up on the side of a Gatorade bottle or something and see that there are a lot of ionic compounds in there. Sodium chloride, magnesium chloride, etc. That is bonding in a nutshell. This is Miss Heaton signing out. Here's the copyright information for the lab activity that we just did. If you would like more information, you can check out the link there to see more of this curriculum.